Hello, pre-calculus folks. This is Mr. McAllen and day 2 of Unit 7 for working with identities. And today in class, we noticed there was quite a few questions as far as what to do with identities. So the first thing we're going to do is you guys worked on problems in class today. And I'm going to just show you how to go through all the solutions very quickly. But remember, the thing you must have is you must have your note card. So hopefully watching me do these solutions and referring to this note card will help you. Now, the thing that people don't understand about identities is that this is a different type of math in terms of an identity means these expressions are identical equations. For example, with this Pythagorean identity that is written down here, the sine squared plus cosine squared equals 1, that is an identity that it means that no matter what you put in for x, this equation will always equal 1. And as a result, an identical equation allows you to rewrite it in several different forms. So here I could, if I wanted to, rewrite this identity as sine squared of x minus is equal to, and I'm going to subtract that to the other side. So it'd be 1 minus cosine squared of x. So this would also qualify as an identical equation. And all I did was just a basic mathematical manipulation to the first equation. And, I can manipulate this again, and I can rewrite it as saying what cosine squared should be equal for. If I solve for cosine squared, I'm going to get 1 minus sine squared of x. So there are all sorts of things that you're allowed to do with these identical equations or identities, and I'm going to show that to you in this video. And then I'm going to show you the second piece of information that we're going to need for tomorrow. So if you feel like you handled the worksheets fine for today in class and you check your solutions, you can fast forward the video till you get to objective 2, which we'll be talking about another specific strategy for working with sines and cosines. But we'll get to that in a minute. Let's just go through these problems really quick. On the first identity, I see that this looks a lot like the first Pythagorean identity. So if I just simply consider moving the sine squared to the other side by subtraction, I can just rewrite this as a simplified identity or a simplified function as this cosine squared of x, because I know from the earlier expression that cosine squared is equal to 1 minus sine squared. Over here, I notice I have a trig ratio squared plus 1. So whenever I see a squared trig function, I kind of think it might be a Pythagorean identity. So I'm going to look actually at this one, and I see here I have 1 plus cotangent squared, and that matches this. So in place of writing that, I'm going to just write cosecant squared of x. On the next one, I see I have cosine and tangent. So I'm going to look around and try to find a replacement for tangent. Now, tangent offers up 2 replacement identities. I could either replace it with sine over cosine, or I could replace it with 1 over cotangent of x. And when I do the first replacement, I'm just going to write cosine of x, just bring that down, and I'll replace the next one with sine of x over cosine of x. That was from this identity. I get a nice easy mathematical expression. I see the cosines cancel, and that is equal to just the sine of x. So this leads me to the next thing that came up in class today was students were wondering what type of math is going on between these 3 functions. And when you don't see any symbol at all, you have to assume that it's multiplication. So in this next expression, it's saying I have a cosine times cosecant. So what you want to do is let's change this cosecant through our reciprocal identity to 1 over sine. So I have cosine of x, and I'm going to replace this as 1 over sine of x. And because it's multiplication, I have cosine of x over the sine of x. And hopefully at this point you see that you have the cotangent of x. So you would first change that to its reciprocal identity. It should be 1 over sine. You notice that you have cosine over sine, which is just the cotangent of x. Next problem on number 5, we're going to switch tangent to sine over cosine. And then cosecant, I'm going to switch to 1 over sine of x. And when you see writing it out in this form, and since they're all being multiplied by each other, you should see certain things cancel. Cosines cancel, and the sines cancel, leaving you with a value of 1. I'm going to try the same approach on number 6. I'm going to switch tangent to sine of x over cosine of x. Switch cotangent. Cotangent identity is up here. It's cosine of x over sine of x. And I've got this plain old cosine of x. So when I multiply these through each other, you see that the sines cancel, the cosines cancel, and you're just left with plain old cosine of x. Now, of course, there's another way you could have gotten through this identity. There might be other solutions that will help you simplify, but these are the way I'm doing it right now, and there might be alternative ways to get through these problems as well. So if you have a question, because you did it a slightly different way, you can surely ask me that in class tomorrow or the next time we see you. And so now let's get on with the last few. We have on number 7, it's the secant times cosecant times cosine. Well, I'm going to turn secant into cosine of x. I'm going to turn cosecant into 1 over sine of x. These are from my reciprocal identities, and right here. And then I have just plain old cosine of x. So now I'm multiplying these through, and what you see is a cosine will cancel with this cosine, leaving you with 1 over the sine of x. So that would be a good place to stop. You could also change that to just cosecant of x also. Next one, I see 1 minus sine squared of x again. That is Pythagorean identity, just with the sign moved to the other side. So I'm just going to rewrite this as secant of x, just bringing that first one down. And then this will be just cosine squared of x. Now, cosine squared of x cancels with the secant, but only one of them, because secant squared of x is 1 over cosine, and this is cosine squared of x. So when you do this cancellation, make sure that you only cancel out that exponent in that one trig term, and we end up having cosine of x as our final answer. Last one, we have tangent squared of x plus 1. If you look at your identities, you're looking for the replacement. So I'm going to replace it with secant squared of x. And if you notice, cosine squared of x is being multiplied by secant squared, which is 1 over cosine squared of x. These two cancel out and leave you with just 1. Okay, so now if you have finished up your homework or checking out your solutions from class today, the homework for today is to watch this part of the video for the second objective. And the second objective just says to discuss, we want to just discuss the strategy for simplifying trig expressions. The strategy is whenever you see a trig expression and they want you to simplify it, one of the things that you could do is you could just change everything to sines and cosines where possible. So if it's already in terms of sines and cosines, then I would go on to I would try something else to simplify. But if the expression, like for example, looks like this, cotangent of x times the sine of x, one of the things that you should consider is use your identity to switch the cotangent to sines and cosines. So what I'm going to do is I'm going to be sneaky here, and I'm going to just like take that, and I'm going to copy that down below. Hopefully it doesn't mess things up. Let's see what happens. Okay, so I have my note card down here right next to it. I want to switch cotangent to something to do with sines and cosines. So I look for cotangent and the identity where it switches it to cosine over sine. I'll just rewrite cotangent as cosine of x over the sine of x, and I'll multiply that by what I originally had, which was sine of x. And hopefully you see, because I made that switch to sines and cosines, that these cancel and my identity just canceled out and simplified to an expression of cosine of x. The second example is when you're dealing with a fraction. Now you need to remember how to cancel fractions with fractions. For example, if you have 3 over 4 divided by 5 over 4, if the denominator is the same, you can cancel it. Denominators can cancel denominators, numerators can cancel with numerators, and we end up with 3 over 5. Or You can remember with complex fractions that when you have 3 over 4 divided by 5 over 4, you multiply by the reciprocal when you're doing division. So 3 over 4 times 4 over 5, that would cancel, again, leaving you with 3 over 5. I don't care how you remember how to do this, just you should have some experience with some fractions from before. And in this case, for example 2, we have cotangent of x that we're trying to simplify with the sine of x. So again, using the cotangent expression, we're going to switch it to sines and cosines. So I'm going to write cosine of x over sine of x. That is the replacement for cotangent. And I'm going to divide that by the sine of x. Now when I have this, the sine of x does not cancel out with the sine of x in the bottom because sine of x here is over 1. So you can write it out this way, cosine of x over sine of x divided by cosine of x, divided by sine of x over 1. And then remember that when you divide by a fraction, you multiply by the reciprocal, cosine of x over sine of x times 1 over the sine of x. And your final expression would be cosine of x, top times top, bottom times bottom, the sine of x times the sine of x, which would be sine squared of x. So this would be your final expression for simplifying this in terms of sines and cosines. I hope this video is helpful to show you what to do in our next step. And remember, in the worksheet that we work on tomorrow, it's going to be simply taking any expression and switching everything that you can to sines and cosines from our identity note card. So make sure you have your note card and make sure you have your worksheets. Have a good day.